Hi, I'm here to talk to you about ocean temperature. That's the sixth topic in our topics and research section here for your climate change project. So if you're working on your climate change project, I'm here to tell you about this one. What I'm going to do is walk you through all the sources in order, and we're going to try and help you answer your questions and make sure that your project is really solid and that you know what's going on. If you need more help as you go, just let me know. But we'll get started here. First source is going to be climatekids.nasa.gov/ocean. It's going to tell you about the ocean, which is probably useful since we're looking at ocean temperature. Okay. Also on Climate Kids, there's a bunch of other information here. We're in the weather and climate section. If you want to look at some of the big questions or things like that, Climate Kids is really cool. I know it sounds like it's like for little kids or whatever, but it's actually really useful for anyone. It breaks down the information in ways that like it's just easier to read, you know, instead of having like all these fancy words and stuff, which you'll see. Don't worry, you'll see that. Here we go. So what's happening with the ocean? All right, well, the ocean is about 70% of Earth's surface. It's a big part of our environment. Most of its job is to soak up energy from the sun and other places and distribute that throughout the Earth. It also absorbs some of the Earth's carbon dioxide. Why does that matter? Well, we all live on land, right? But without the ocean, we wouldn't be able to do a lot of things. The ocean's quite deep. It takes up a lot of space. So it contains 97% of the water on Earth. The rest of that is fresh water on your surfaces and your glaciers and things. It just is important for our environment. It's a big role, like it says here, soaks up energy. I don't know why it says that twice. It just does. But how does it work? So this explains kind of how the ocean soaks up energy. So there's a video you can watch to help you understand that as well. And this video is going to help you understand that process. But the ocean, it takes in energy from the sun, or really from anywhere. It takes in energy. It takes in CO2 as well. It absorbs heat from the atmosphere. Basically, the top few meters of the ocean store a bunch of heat, and that's useful. But as the planet warms, most of the extra energy, the extra heat is going into the ocean. If the ocean gets too warm, then the things living in it, they're not going to be able to survive, so they'll die. So you can read through here about how that affects the food chain and how that affects everyone. And coral is another creature that's in there that's going to be in trouble because coral lives close to the surface, and that's something that you need to think about. So coral is really useful for providing habitat and things like that as well. Then also here, the ocean soaking up carbon dioxide. So actually, carbon dioxide that's in the air can get pulled into the ocean. And what happens is it creates an acid. So here's the pH scale, right? So ocean water is usually really close to neutral, which is what pure water is, right? But it's just a little bit basic because it has all the salt and stuff in it, right? But as you add more CO2 to the ocean, it actually goes down the scale here closer towards an acid. And that acid can have adverse effects on the things that live in the ocean, like coral and things that make shells. Anything that makes an exoskeleton or a shell, that stuff's made of calcium, which dissolves really easily in slightly acidic conditions. So even something like vinegar, right? You can dissolve like really weak calcium and stuff in vinegar, which is a really weak acid. But yeah, as you go more acidic, you're basically making it impossible for them to make these things. So their skeletons are made of that same shell-like material, the coral. So anything that secretes a shell or like corals or stuff, they're not going to be able to build essentially their home to live in, which is bad. They won't be able to survive. So that's bad for the food chain. It's bad for just like it cycles through, right? Because like the simple stuff that gets its energy here, like the corals and stuff and things that eat those things, are going to not be able to have food. And then those things won't be able to survive. Then eventually it gets to, us or things we eat, and that's bad. So how does it affect the climate? Well, if the ocean's getting warmer, it's going to be carrying that heat with it, right? So that's what's actually warming up the East Coast, has like this effect where this weather gets pushed up the coast, and it's because of this ocean circulation. You guys hopefully learned about this great conveyor belt, the way that the ocean circulates and that heat is carried through the water last year. But what happens is, if you're increasing the temperature, you're changing the temperature. Same thing's happening if more ice is melting, making the water colder in those areas, right? Then that's affecting the circulation, which is bad. And then here you can read more about kind of what salt does and things like that. So an estuary, by the way, that's brackish. Brackish is like when fresh water, like a river, flows into the ocean. That's what an estuary is. It's like this. It's a mixture between freshwater and saltwater. So you can read about that a little bit. But this site does a really good job of kind of telling you the what. It doesn't tell you how we get this information. It just kind of tells you what's going on and why that's important. So the ocean, it absorbs heat, it absorbs CO2, and if there's more energy, more heat energy, and more CO2, then the ocean's going to absorb more of it, which is going to have effects on the things that live in the ocean and the things near the ocean, like you and me. All right, so this article is in here a lot. This article has a ton of jargon, but what it's basically getting to is that warming water causes ice melt. So there's ice that runs off onto the water and it lives on top of it, right, like this. this ice that's touching this water can melt, and that process is called basal melting. And that's all explained right here. This is basically what you need to know if you're doing this particular topic. This article is like really, really, really detailed, but basically what it's saying is scientists have found out that basal melt, which is melt from the water that the ice is sitting on top of, melting the ice, right? Which it says right here. The melting of ice shelves from underneath of individual ice shelves, the floating extension of glaciers. That's what an ice shelf is. So we found that that's happening. And what we found out is that that's happening quite a bit. And a lot of our ice is melting because of this basal melt, which happens when the temperature increases. And that's pretty much all you need to know. If you want to read into this in more detail, you can. If you're looking at for more detail from this article, you should go to my video on ice, the ice and glaciers video. I explain this diagram in great detail. I walk you through this article for like 10 minutes. It's really nice. But if you have more questions, just let me know. I'll help you out. Okay, so here's your third source here, which is the most powerful evidence scientists have of global warming. That's a big headline, right? The ocean is really the key to this whole thing. It's like how we know this is happening. The oceans hold the story of a planet warming as fossil fuels are burned. So a lot of people are saying, oh no, humans aren't causing climate change, but we're saying, hey, this is what's happening, and here's how we know. So you can actually measure this. You can measure the CO2, and you can measure the temperature in the ocean. You can see it's gone up. So Earth's temperature is rising, and it isn't just the air. More than 90% of excess heat trapped by greenhouse gas emissions has been absorbed into the oceans that cover most of our planet. The temperature is rising too in the oceans. Okay, so the accrued heat, that's heat that's gathered up in the ocean, is really the memory of past climate change, right? So it's not just the amount of warming that is significant, it's also the pace, that's the rate at which it's warming, right? So here it talks to you about that. So here is a nice graph, which I'd probably think about showing people from in your project. You can take a screenshot of it, kind of like that, and then you can drop it in there, right? Make sure you cite your source. Okay, so the oceans absorb 90% of excess heat trapped by greenhouse gas emissions. 2015, 2016, we reached 2,000 meters. Sorry, the heat in the upper 2,000 meters of the ocean reached its highest point on record. So the highest we've ever recorded a temperature up until this point. This article is a couple years old now, but in 2015, 2016, we were at our peak, right? We've never seen it higher. So this actually mixes a bunch of data together. You don't need to use the tan one, but the blue one is our CO2 measurement. So this is the CO2 in the atmosphere. You can see that it's going up. And then the black line is the temperature of the ocean. You can see that that's going up as well. So those things look like they're following the same trend. And what we're trying to say is that we think these things are related because we know that CO2 increases the greenhouse effect, and more CO2 in the atmosphere, warmer atmosphere is going to warm the oceans. So we're saying these things are probably related. And then here's a nice diagram that shows you kind of how global warming works. Okay, produce CO2 and other greenhouse gases, increase the greenhouse gases in the atmosphere, solar radiation comes in, the heat is trapped, things like that. Okay, so you can kind of see how that works if you want to see it. That's pretty much everything you need to see here. There's some extra information here about ocean temperatures and showing how it's getting warmer and warmer, and you can kind of see how this scale is showing you that the red is really warm and the blue is quite cool, but most areas in the world you're seeing these increases, right? Now some areas you're seeing cooling happening more, and you can kind of connect that to what I was talking about with the temperature cycling in the ocean earlier. As you change temperatures around the ocean, it changes the way that the water is flowing, and that's going to bring some cold water to the surface in some new places. Which could be causing some of this. But if you look at 2017, look at that. There's like barely any not red areas. The ocean's getting warmer, y'all. Now, some of you are like, great, warm water, great. But what does it do, right? Here's what it does. As oceans warm and expand, and the sea rises, right? The increase in ocean heat causes seawater to expand, raising sea level. In 2015, roughly half of the sea level rise was caused by ocean warming. So what we're saying is, yes, the ocean's warming. Yes, that's melting glaciers, but it's not the only thing causing the sea level to rise. There's actually this thing called thermal expansion. When things are heated, they tend to expand. And you're probably thinking, but when you freeze water, ice expands. That's true, but expansion actually happens when you heat stuff up. And if you think about it, right, you heat it up, the particles are moving faster, they need more space to move in, so the object has to expand. So this thermal expansion in your seawater is actually causing, literally the ocean is like fluffing up. It's like, I need more space to store heat. Got to expand the space between my particles, so then it does. That's that article. I mean, it's a good one. There's lots of really good graphics. If you're seeking to understand these graphics and you want help, just let me know. They're really nice things to put in your presentation. Just make sure you cite your source. Last thing, the EPA has been drastically changed. Hopefully some of this stuff is in the archive, but I don't know. Hopefully this is still accurate information. When we first started doing this project, it was, but the EPA has been ordered to essentially delete a bunch of things. Okay, so here we go. This is still looking good, though. This graph is really why you're here. This graph is showing the increase in surface temperatures of the ocean. So anomaly is how different it is than what it was, like what the average was. So you can see that in the late 1800s, early 1900s, our ocean temperature is actually below the average from 1970 to 2000, which kind of makes sense, right? Because we're saying that the ocean has been warming over time. But the calculated average from 71 to 2000 is this zero line. So we were below it for a while, then we spiked above it in the 40s, then we went back down, and now look, we're rising pretty substantially, and you don't see that pattern happening really nowhere else, where it's just temperatures are just increasing a lot. And you can see kind of like there's a yellow line in there, and then there's like a gray outline of it. The gray outline is kind of like the percentage of uncertainty in that data, which means like it could be as high as this, as low as that. We can't calculate it perfectly, so we can't tell you for sure, right? So that's one graph. And then here you can see it visually. This is the overall average change in sea surface temperature. So that's like taking this data and putting it on a map of the Earth. So you can see some places we don't have data, but some places we do. And look, there's some significant increases in some of these places, or even some decreases too, right? We're showing all the data so you can kind of draw your own conclusions. But if you were to look at this, it leads me to believe that the ocean temperature is increasing more or less around the world. So that's something to think about. Okay, that's the whole video. If you need help with anything, let me know. These are really good sources for you, but I understand that this can be confusing. So please let me know if you need help, and I'll be here for you.